Now this illustration deals with grounding and bonding metal cable trays together. Now notice NEC 392.60A, 392.30B3, 392.60C, as well as 392.100E is the sections referenced to review. Now, what is happening with this cable tray system? Notice the mechanical disconnection segments of the cable tray system is permitted. In this case, it's an elevation change. And the elevation change means that each cable tray that is separated there can act as a support, if not over 6 foot. Now, we would be looking at the support of cables, 392.60C as in car. We're looking at sizing that bonding jumper, 392.60B4 and 250.102, as you see the bonding jumper bonding those two separated cable trays together. Now, 392.60 refers to table 392.60B. And notice we can size a bonding jumper to connect those trays together. But we get the sizing of these trays. And we do that in 392.22A, 392.22B, 392.22C, as well as 392.80, because we may have to apply some adjustment factors, depending. Now, when we put all this information together, say that that cable tray was 1.00 square inch area of metal, and say it's a 400 amp overcurrent device in that panel board, then we could take that 1.00 square inch area and go to the table 392.60B for metal cable trays, and it would require, based upon the 400 amp overcurrent device per table 250.122, we could clear a 400 amp overcurrent device with a number 4 bonding jumper. So the thickness of metal of the tray with the little sticker on it telling us, that is what determines the sizing of the bonding jumper based upon the overcurrent device, because the tray thickness along with the bonding jumper will clear a 400 amp overcurrent device when we reference our table 392.60B. And that's what this illustration is showing, is that you do not have to have a continuous cable tray for an elevation change or for a directional change. And that's what this illustration is illustrating.